Subscribers to this channel receive carefully researched ebooks, detailed videos showing real DIY woodworking projects built step by step, and exclusive timber-related material that is not published publicly. The focus is on understanding wood as a material across time, how it changes, how it fails, and why historical practices still matter when durability is the goal. Modern builders often believe that the faster wood reaches a usable moisture level, the better the outcome. That assumption feels efficient, practical, and technically sound. But it hides a long-term consequence that doesn't show up until years later. Timber dried too quickly may meet specifications, yet lose strength, stability, and resilience over time. Now, this isn't just a cosmetic issue. It actually affects load paths, joint integrity, and, well, how wood survives environmental stress. Once you really understand what happens inside the fibres during rapid drying, it becomes clear why so many historic structures outlast modern ones made from so-called better lumber. Wood is not an inert material. Even after a tree is felled, its internal structure continues to respond to moisture gradients, temperature, and, various kinds of stress. So, the goal of drying is not simply to remove water. It's actually to allow the cell walls to adjust gradually as bound water leaves the wood. When this happens too quickly, the outer layers shrink and harden before the interior can respond. And, this creates internal tension that doesn't always express itself immediately. The timber may appear straight, stable, and ready for use. But, those locked-in stresses remain. Over time, under load or environmental cycling, they begin to release unevenly. That's when checking deepens, joints loosen, and structural performance declines. Kiln-drying exists because modern construction demands speed and uniformity. It reduces drying time from months or years to days or weeks. It produces lumber that meets predictable moisture targets and minimizes surface defects that buyers can see. From an industrial perspective, it makes sense. The problem is that, kilns tend to prioritize moisture content numbers rather than really considering the long-term behavior of the wood fibers. Heat, in this context, accelerates moisture movement, forcing water out of the wood much faster than the cell walls can actually relax. In many cases, especially when dealing with those dense or resinous species, this process actually results in what's called case hardening. The exterior of the wood becomes rigid, while, interestingly, the core remains under compression. Historically, builders simply didn't have the option to rush this process, and honestly, that limitation often worked in their favour. Before kilns, timber was air-dried under shelter, exposed to wind but protected from direct sun and rain. Logs or beams were stacked with spacing that encouraged airflow without creating rapid surface drying. This allowed moisture to leave the wood slowly and evenly. In colder climates, winter drying played an important role. Freeze-thaw cycles moved moisture gradually and encouraged uniform shrinkage. In warmer regions, shade and orientation really mattered. The goal was consistency, not speed. These methods didn't eliminate defects, but they did reduce internal stress. Over time, this produced wood that moved less, cracked less deeply, and handled load more predictably. One of the most overlooked aspects of drying is honestly the difference between surface moisture and internal equilibrium. A board can feel dry to the touch and even measure within acceptable ranges, while still carrying moisture gradients internally. Rapid drying exaggerates this difference. When such wood is put into service, environmental changes slowly pull moisture from the core or push it back toward the surface. The wood continues to move long after installation. In framing, this shows up as nail pops, twisting and gaps. In joinery, it results in creeping joints and reduced bearing strength. Historic builders expected wood to keep changing, you know. Their joinery allowed for it. Modern systems, though, often assume the material is finished changing when it leaves the yard. Strength loss from rapid drying isn't dramatic or immediate. It's incremental, really. Microfractures form within the cell walls when shrinkage happens too fast. These fractures don't cause failure on their own, but they reduce the wood's ability to absorb stress over time. In beams and posts, this means reduced resistance to cyclical loading. In tool handles or structural pegs, it means brittleness instead of resilience. The wood still works, but it works closer to its limits. This is why reclaimed timber from older structures often outperforms newer lumber of the same species. It wasn't rushed into its final state. Modern standards focus heavily on moisture percentage. While important, this number alone doesn't describe how the wood reached that state. Two boards at the same moisture content can behave very differently depending on drying history. Wood dried slowly tends to have more relaxed fibres and, more stable dimensions overall. On the other hand, wood dried quickly may reach the same target moisture content, but it can actually retain a fair bit of internal stress. The difference between the two really only becomes obvious with time, load, and environmental exposure. This distinction, it mattered deeply to historical builders, even if they didn't describe it in modern scientific terms. They would judge timber by its sound, its weight, how it moved, and how it behaved over the seasons. When modern timber fails prematurely, honestly, the causes often trace back to drying stress rather than the species or the design itself. Beams can split along grain lines that really shouldn't be critical. Posts might develop deep checks that compromise their bearing surfaces. And, boards can cup or twist in ways that just weren't present at installation. These failures aren't dramatic collapses. They're gradual losses of performance that, shorten a structure's functional life. Historic structures show different patterns. Cracks are often shallow, movement is predictable, and components continue to function despite age. The difference lies in how the wood was allowed to become wood. For those concerned with long-term resilience, speed is rarely the ally it appears to be. Timber meant to last through decades of environmental change, well, it really benefits from slow adaptation. Drying is the first major test of that adaptability. When wood is rushed through drying, it enters service already stressed. But when it's allowed to adjust gradually, it carries less internal tension and, handles future stress better. This principle holds whether the structure is a house, a boat, or even a storage frame. Even when using kiln-dried lumber, understanding drying history honestly, it informs better decisions. Allowing lumber to acclimate longer before use, avoiding over-constrained joinery and respecting grain orientation all help to mitigate the effects of rapid drying. More importantly, recognizing that wood is never truly finished, changing encourages designs that accommodate movement rather than resist it. That mindset is inherited directly from historical practice. The drying shortcut is, convenient, but convenience comes at a cost that isn't paid immediately. It's actually paid over time, through maintenance, repair, and, eventual replacement. Understanding how wood responds to drying speed really does restore a deeper respect for the material and, honestly, the patience it requires. Historical builders didn't avoid shortcuts because they were ignorant. They avoided them because, through experience, they learned what wood remembers. If this kind of material-focused, historically grounded understanding matters to you, consider subscribing to the Old World Timber email list. This knowledge exists to help woodworkers, builders and historians work with wood as it truly is, not just as it's sold today.